Hi everybody. In this video we're going to go through our unit today on scientific notation and putting numbers in order. The first thing we're going to talk about is scientific notation. As we go through these notes, please pause the video periodically and make sure you type in the answers that I type in with me. So the first thing says, a number expressed in scientific notation when it is written as the first two digits of a number and a power of 10. The number must be smaller than 10 or equal to 1 and the power of 10. When do we use scientific notation? When we use scientific notations when we have a number written very largely and we want to go ahead and make it smaller, easier to read. So here's a number written in long form, 4,200,000. Here it is written in scientific notation. We have our decimal between 1 and 10, and then we have our power of 10 over here. Let's look at some examples. So first they gave me the number 67,000. So we want to turn this into a number in between 1 and 10. To do that, what you need to do is you need to make sure you start back here where the decimal would be and move it until your number is in between 1 and 10. If I move my decimal all the way here, that would be 6.7. So I'm going to go ahead and I'm going to say 6.7. Now I need to multiply it by a power of 10. So I'm going to say times 10. I'm going to use this little caret key, this feature right here above the 6. You press Shift 6, you can get this key to go ahead and type it in. Next, to figure out what the power is, look at how many times you have gone ahead and moved your decimal. 1, 2, 3, 4 times. So this will be to the power of 4. So 6.7 times 10 to the power of 4. Now, normally we know when we'd be writing it, it would look a little different. But because we're on a keyboard today, just press the caret feature and then 4. And that means that's a power of 4. Sometimes they're going to give you numbers as decimals. If you look down here, this number is not a number in between 1 and 10. So we need to move our decimal so that it is. If we move our decimal right to this location and make this 9.3, then it would be a number in between 1 and 10. So I'll say 9.3 times 10. And I'm going to count how many times I moved my decimal. I moved it once, twice, 3, 4 times. So I'll use my caret button and I'll say 4. But here's one thing to remember. When I moved my decimal, I moved it so that this number here, 9.3 times 10 to the 4, it should be getting smaller. It should be getting to 0.00093. So if this number, my original number here I started with, if it is smaller than 1, which 0.000093, that is definitely smaller than 1, then that will always let you know that you have a negative exponent there. As we go through and do more examples, I'll show you more of what I mean. Please make sure if you haven't done so, you've typed both of these answers into your notes. The exponent shows what you've just seen. The exponent shows the number of loops and the directions to move the decimal place. So generally, the positive exponent will move you right. The negative exponent tells you how to move left. I'm sorry, I had that backwards. I'm going to say the positive exponent. Yep, no, that was right. Tells you to move left. So that's my example down here. We have 8.5 times 10 to the power of 5. So if I had 8.5, and I'll type 8.5 in here. Imagine I'm moving this decimal to the right. If I moved it to the right one time, that's 85. If I were to move it again, every time I keep moving it to finish those 5 hops, I need to add a 0 because there's no number over there. So I moved it once, moved the 5, again, one more time, and then a final time here. So I started with my decimal in between the 8 and the 5, and I hopped 1, 2, 3, 4, 5. So you would end up with 85,000. Next, we're going to show you how to move a number from scientific notation to normal standard form. So if you go ahead and do that, this one's, I think, much simpler. Well, all you're going to do is write your original number, 5.2, and because it says -3, 10 to the power of -3 there, whoops, let me move that away. So if I had 5.2, because it's a -3 right here, that lets me have to move my decimal to the left. So if I did that, I would actually have to move my decimal to the left past the 5, that'd be 1 hop. I moved it again, there'd be a 0, that'd be 2. If I moved it one more time, there'd be another 0, 3, and then there would be my decimal. Just to finish, you always want a number in front of your decimal. You can't have a decimal start a number off, so I'm going to put 0 there since it won't make a difference. And just to show you what I did, if our decimal was here, I moved it 1, 2, 3 times. I had to hop 3 times to the left. Let's go try this next one. This one says write 7.801 times 10 to the 0. Well, guess what? If I had 7.801, the 0 being the power here tells me not to move my decimal at all. So that means we are done. If there's a 0 there, that's not negative, that's not positive, that means nothing. That means you're not going anywhere. So you would just leave your number alone, and that would be your answer. Let's go to the next slide and we'll talk about our next topic. So for the next topic, it says we're going to be putting numbers in order from least to greatest, greatest to least. So first thing we need to do is convert all values to decimals. Once we have them all in decimals, what we need to do is align each decimal. We need to line up each decimal. And we are going to fill in the empty spaces so that each decimal has the same number of zeros. So we'll fill in the empty spots, empty spaces, so that each decimal has the same number of zeros. All right, a better term you can think of as digits, the same number of digits. And finally, compare the values. You need to be, one thing that I always say is think of money. If you think of money, that is something that helps you. So we're going to put these in ascending order. And I'm going to show you what I mean by first putting these all in decimal form. So first I have 1.5 times 10 to the second power. That lets me know I'm going to have 1.5. I need to move this decimal once, twice to the right. So if I move it once, it'll be right there. If I move it a second time, it will be 150. And that's where my decimal will be. Next, I have 50%. If I have 50%, that would be 0.5. I'm going to make sure these decimals are lined up though. So 0.5. The next one I have is 0.25. That's already in decimal form for me. So that's nice and easy. 0.25. And the final one will be 7/10. And if you type 7/10 into your calculator, you'll get 0.7. So now that I have all of my decimals lined up, what I want to do is fill in these empty spaces behind them so that they each have the same number of digits there. So as an example, if I go all the way up to this 150, I need to add a 0 here and a 0 there so it has just the rest of everyone else. Add a 0 behind there and I'll add a 0 behind my 7. So now I can see that I have the same number of digits or zeros back here, and I can line these up. To put in ascending order, if you're ascending, that means you're starting at the bottom and then you're going up. So you're starting with the smallest and you're going to the biggest. So first we need the smallest number. To figure out which one is the smallest, what I always do is I start first I go from left to right, and I start first in the hundreds column and I work my way left. So first I see a 1. The rest of these have nothing there, so that means this is automatically my biggest. So I'll just put a 4 next to this, so I know this will be my biggest number. Let me change the color of that. We'll make that a nice, beautiful blue. So I know it's going to be, this will be my 4th. That'll be my biggest because there's a 1 here in the hundreds column. Nothing else has a 1 there. Next, I'll check my 5. Still nothing else. Then I look and I see zeros. So all of these are zeros. I can't do anything here. I'll go to my next aisle. So in this aisle, I see 5, I see 2, and I see 7. Well, just looking here, if I have a 5, a 2, and a 7, I know 2 is the smallest. So I'm going to go ahead and I'm going to say that the 2 here, the 0.25 would be my first, and that would be my smallest number. If I keep looking at this column, I see a 5 and a 7. Well, I know that 5 is definitely smaller than 7. So I'll add my 5 there. That will be my second biggest one. And then finally, if I had to pick my last one, my third one would be 0.7. And I already knew that 150 was the biggest, just because that was stood out to me right away. And now that you know that, you could go ahead and rewrite your answers down here in the box. So we said the smallest would be 0.25, followed by 50%. After that, we had 7/10, so I'm going to say 7/10. And then the final one was the one we had in scientific notation, 1.5 times 10 to the power, and make sure you press the caret symbol, of 2. So that's how we're going to do this for the order. As long as you have your decimals lined up and then you fill in your zeros behind, all you have to do is look from left to right and see which one's bigger or which one's smaller. So let's go to this one. This will be our last one we'll look at. So same rules apply, except this time it is in descending. We will be at the biggest point, our greatest number first, and we're going to go down. So we're going to go from greatest to least. So let's write these numbers out like we did last time. First, we have 0.3. Next, we had 8.2, 8.12, but because it's 10 to the power of -3, that means we need to move our decimal one place to the right. Now we're actually going to move it again and make it 2 places to the right. And if I move it one more time, it would look like that, 3 places to the right. It started here behind the 8. It jumped 1, 2, 3 places to the left there, and our things moved right. What I'm going to do now is just move it over so that my decimals line up. When you're working with paper and pencil, always that makes it a little bit easier. Always make sure they line up. That is the key. Next, we have 3%. 3% is 0.03. And then the next one would be 1/4, which would be 0.25, or 25 hundredths. I'm going to make sure I have all the same amount of zeros and digits lined up in my problem right here. So we'll make sure everything lines up correctly. I'll fill in the rest of these, which I always recommend you do, because that way you can kind of really see everything the same way. It's all in the same playing field. So descending order means we need to go from greatest to least. So I'm going to go left to right, and I'm going to pick the numbers from greatest to least. And I'll write this one in red. So for this one, first start on the left and work your way right. So first there is a 0. So these are all tied. There's no one's the greatest one yet. If I go to the right, now I can see which number is the biggest here. I have a 3, I have a 0, and a 2. So right away, because I see that there's a 3 here, I know that that is my biggest number. So that will be my number 1. That will be the first thing we have. Next, we'll take a look at, on here, I saw if there was a 2 and the rest were zeros. So that lets me know that this one is my second biggest number. Now it looks like we have a tie between these two. They both have zeros. So to break the tie, you just go to the next row over. And I'll look in this row right here. Maybe I'll put a little mark so you can see I'm looking right here in this row. And I already know this one's out, and I already know this one's out. So I'm just looking at these two, and here's a 0, and here's a 3. So I know 3 is bigger than 0, so then that means this has to be my third one. And finally, the one above it, the one that was our scientific notation number, has to be our smallest. So now I know the numbers, what order they go in. I'll go ahead and write them out for us, and we'll put them in our little box and we'll record everything. So my smallest one we said was, my largest one was 0.3, also known as 3/10. My next one was going to be 0.25. So we'll have 0.25, also 1/4. So I'll write actually that as the fraction, 1/4. Next, we had our number that was 3%, so just 3%. The final one was the one in scientific notation, 8.12 times 10. Make sure you press your caret symbol to the power of -3. So thank you for watching. This was just a brief review of what we learned in this class for this week. If you have any more questions, please reach out to your teacher for help. Thank you for watching.